You have been told a fairy tale your entire life. A comfortable, clean, neatly packaged story about how everything began. Science textbooks say the universe is approximately 14 billion years old, that before the Big Bang there was absolutely nothing, no space, no time, just a perfect and total absence of everything. And most people accept that story without a second thought, because it sounds authoritative, and because questioning it feels like stepping onto unstable ground. But that story is not just incomplete. It is, at its foundation, intellectually lazy. And today, that foundation is going to crack. The question on the table is one of the most extraordinary in the history of human thought. Can light be older than the very universe it travels through, not older by a few million years? Older in a way that breaks the standard timeline entirely. And the answer, when you follow the mathematics with full honesty, is yes. Light can predate our universe. Light has crossed the boundary between one cosmic era and the next, and we have detected the evidence of that crossing written directly into the structure of our own sky. To understand how that is possible, you first need to understand something fundamental about what light actually is, not the poetic version, not the simplified classroom version, but the precise physical reality. Light does not experience time. A photon, the basic particle of light, carries zero mass. And according to the iron rules of Einstein's relativity, an object with zero mass has no choice but to travel at the universe's absolute speed limit, 300,000 kilometers per second. At that velocity, something extraordinary happens to the relationship between space and time. Both collapse entirely. For a single photon traveling through the void, the concept of duration does not exist. The concept of distance does not exist. A photon born in a star and striking your eye arrives, from its own perspective, in the same instant it was created, regardless of how many billions of years passed for everything else in between. That is not a metaphor. That is the precise output of the equations governing relativistic physics. And once you genuinely absorb it, a door opens into a picture of cosmic reality that the standard model of cosmology has been quietly avoiding. Think about the far future, not thousands of years from now, not millions, but the genuine long-term trajectory of this universe taken to its mathematical conclusion. The galaxies visible in tonight's sky are already fleeing from each other at staggering speeds. That expansion will continue. Stars will exhaust their fuel and extinguish one by one. The cosmos will grow cold, dark, and empty. Physicists call this thermal death the final state of maximum entropy, where no useful energy remains and nothing further can happen. It sounds like an ending, but what comes after that ending is where the physics becomes genuinely astonishing. In that distant future, the only structures remaining in the cosmos will be black holes, solitary gravitational monsters consuming the remnants of dead galaxies across timescales that dwarf anything our intuition can picture. But even black holes are not permanent. Stephen Hawking demonstrated that they slowly radiate energy through a quantum process, losing mass with agonizing patience until, after an almost incomprehensible span of time, they vanish entirely in a final burst of radiation. When the last black hole completes that evaporation, the universe will contain exactly one thing: not matter, not stars, not any structure of any kind. Only light and infinite, frozen ocean of photons drifting through an unimaginably vast and featureless void. And that is precisely where the story stops being depressing and starts being the most mind-altering discovery in modern cosmology. Picture that final state carefully. An infinite universe containing nothing but light photons with zero mass, drifting through a void with no stars, no planets, no atoms, no clocks, and no rulers. No material object of any kind to measure distance. No physical process of any kind to mark the passage of time. The universe, at the absolute endpoint of its existence, has lost every instrument it ever possessed for measuring itself. And that loss of measurement is not merely a practical inconvenience. It is a mathematical event with consequences that reshape the entire concept of what a universe is and how one ends. Here is the insight that changes everything. Size, as a physical concept, requires a reference. When you describe an object as large or small, you are always making that judgment relative to something else, another object, a known scale, a familiar comparison. Remove all material reference points entirely, and the concept of size loses its physical meaning. A universe containing nothing but massless photons has no internal ruler. It cannot measure its own dimensions. And a system that cannot measure its own size is, from the perspective of the mathematics governing that system, indistinguishable from a system of any other size, including a system of no size at all. This is the branch of mathematics known as conformal geometry. Think of a triangle drawn on a sheet of paper. Now imagine the same triangle scaled up to the size of an entire galaxy, every angle identical, every proportion preserved, only the scale changed. If you remove every physical object that could serve as a measuring reference, You cannot distinguish between the two triangles. The shape is intact. The scale has become meaningless. Apply that principle to a universe, and something extraordinary follows. An infinitely expanded, cold, empty cosmos filled only with massless light is in the precise language of conformal mathematics geometrically identical to an infinitely small, hot, dense point of concentrated energy. Read that again slowly. The frozen, infinite endpoint of a dying universe and the explosive, microscopic origin point of a new one are not merely similar in certain equations. They are the same geometric state, described at different scales that the mathematics itself cannot distinguish. The Big Bang is not a miraculous exception to the laws of physics, a moment where equations break down and reality appears from nowhere. It is a transition. The vast, cold, light-filled graveyard of one universe collapses mathematically into the concentrated singularity that ignites the next. The end and the beginning are not separated by a wall. They are the same boundary, approached from opposite directions. But that immediately raises a question that cannot be avoided. If our universe is one link in a chain of cosmic cycles, if a universe existed before ours, expanded until it died, and its death became our birth, what happened to the light from that previous universe? Light has no mass. Light does not experience time. For a photon crossing the geometric boundary between one cosmic era and the next, there is no barrier. There is no threshold to cross. It simply continues, which means the light saturating the background of our cosmos today may not all originate from our own universe's history. Some of it may be genuinely older than our time, inherited from a reality that collapsed before our clock ever started running. And the critical question is whether we can detect any trace of that inheritance, whether the photons that crossed the boundary left any mark on the structure of our universe that distinguishes them from the radiation born within our own era. That is exactly what the analysis of the cosmic microwave background, the oldest light our instruments can directly observe, has been quietly revealing to those willing to look past the standard interpretation. The cosmic microwave background is the thermal echo of our universe's earliest observable state radiation, emitted approximately 380,000 years after the Big Bang, when the cosmos had cooled enough for light to travel freely for the first time. It fills the entire sky uniformly, a fossilized sea of microwave radiation that encodes information about the conditions of the early universe. Most cosmologists who examine the detailed temperature maps of this background see what they expect to see: a nearly uniform field of radiation with small, random fluctuations consistent with the standard model of cosmic inflation and early structure formation. But a different analytical approach, one rooted in conformal geometry rather than standard cosmological modeling, reveals patterns in that data that the conventional framework struggles to account for. Specifically, circular rings in the temperature distribution, concentric patterns of anomalous thermal readings centered on specific points in the sky. These are not instrument artifacts. They are not a statistical noise produced by the measurement process. They are real features in the data, confirmed across independent analysis of the most advanced satellite observations ever conducted. The explanation for those rings, within the framework of cyclic cosmology, is both elegant and deeply unsettling. In the universe that preceded ours, there were supermassive black holes, gravitational monsters, trillions of times more massive than our sun, which spent unimaginable spans of time colliding with each other, radiating gravitational waves, and eventually evaporating through Hawking radiation at the endpoint of their era. That evaporation released enormous concentrations of energy. And because the geometric boundary between cosmic eons is transparent to massless light, that energy crossed into the birth of our universe and left an imprint, a thermal signature stamped into the plasma of our early cosmos, preserved in the microwave background as the circular ring patterns that the conformal analysis detects. These features are called Hawking points, named in honor of the physicist whose work on black hole evaporation makes their existence theoretically possible. They are not predictions made after the fact to fit observed anomalies. The theoretical framework predicted their existence and their general characteristics before the systematic search for them in the observational data was conducted. Finding them where the theory said they should be, with the statistical significance that careful analysis demonstrates, is not coincidence. It is evidence, observational evidence of a physical process that occurred before our universe existed, leaving a detectable mark on the structure of the cosmos we inhabit. The mainstream scientific community's response to this evidence has been, for the most part, dismissal. The circular patterns are attributed to random statistical fluctuations or instrumental systematics. The conformal cyclic cosmology framework is treated as speculative rather than as a legitimate theoretical alternative demanding serious engagement. The attitude is understandable in one sense. The standard cosmological model is powerful, well-tested, and supported by enormous quantities of data. Overturning it requires a very high standard of evidence. But dismissing anomalous patterns in the data as noise, specifically because acknowledging them would require revising a model built over decades of institutional investment, is not scientific caution. It is the prioritization of comfort over inquiry, and the radiation does not adjust itself to accommodate institutional preferences. The paradox that this framework creates, and that its critics seize on immediately, is one of the most fundamental in all of physics. It is the problem of entropy. The second law of thermodynamics is not a guideline. It is not a statistical tendency that occasionally reverses itself under unusual conditions. It is a foundational law of nature, describing the irreversible tendency of any closed system to move from order toward disorder over time. A glass shatters when it falls. The fragments never spontaneously reassemble. Heat flows from hot objects to cold ones, never in reverse. Stars burn their fuel and cannot unburn it. The direction of time itself, at the physical level, is defined by the relentless increase of entropy, the universe always moving from more ordered states toward less ordered ones. If cyclic cosmology is correct, the problem is immediate and serious. The universe that preceded ours had billions of years to accumulate entropy, to move from the clean, low entropy state of its own birth toward the maximum disorder of its death. If that accumulated disorder passed directly into the beginning of our universe, our cosmos should have been born in a state of near maximum entropy. It should have emerged from the Big Bang as a structureless, chaotic gruel, no gradients, no organized structures, no possibility of galaxies or stars or planets forming from it. But that is not what the data shows. Our universe was born in a state of extraordinarily low entropy, an almost perfectly smooth, ordered initial condition from which gravity could sculpt the entire complex structure of the cosmos we observe today. Something reset the entropy between the death of one universe and the birth of the next. Something cleaned the cosmic slate. And understanding what performed that reset is where the framework of cyclic cosmology reaches its most mathematically precise and physically satisfying conclusion. The answer lies in the black holes themselves, in the specific way that gravitational entropy behaves differently from every other form of disorder in the universe. During the active life of a universe, matter aggregates under gravity. Stars form, collapse, and seed the centers of galaxies with supermassive black holes that spend billions of years consuming everything around them: dead stars, gas clouds, wandering planets, diffuse dust. As they consume this material, they absorb the entropy associated with it, drawing disorder behind the gravitational boundary of their event horizons, effectively hiding it from the rest of the universe. Black holes are, in a precise thermodynamic sense, the universe's entropy storage facilities, concentrating the accumulated disorder of cosmic history within their interiors, where it cannot affect the external cosmos. As the universe approaches its thermal death and the black holes have consumed everything available to them, they begin the Hawking evaporation process, radiating their mass away with agonizing slowness across timescales that make the current age of the universe look negligible. And here is the critical point. The entropy that was gravitationally bound within those black holes, the accumulated disorder of an entire cosmic era, is not simply released back into the universe when they evaporate. Gravitational entropy is mathematically distinct from thermal entropy. When the mass of the black hole disappears, the gravitational deformation of space-time it produced disappears with it. The structural disorder associated with that gravitational field is erased, not transferred, not redistributed, but genuinely removed from the equations that govern the state of the post-evaporation universe. What remains after the last black hole completes its evaporation is a universe from which gravitational entropy has been systematically and completely eliminated. The only thing left is a sea of pure radiation photons carrying energy but no structural disorder of the gravitational kind that defined the complexity of the previous era. And that sea of pure radiation, entering the conformal geometric transition that bridges one cosmic era to the next, carries with it a near-zero entropy state. Not because the second law of thermodynamics was violated, but because the specific mechanism of black hole evaporation, operating across the full lifespan of a universe, performed the reset through entirely lawful physical processes. The universe does not cheat the laws of thermodynamics. It uses them with a sophistication that operates on timescales so vast that the mechanism is invisible from within any single era. This is the complete picture that cyclic cosmology assembles from its component pieces. A universe is born in a low entropy state from the conformal geometric transition of its predecessor. It expands, cools, forms structure, burns through the free energy of its stars, and approaches thermal death. Its black holes spend the final phase of its existence, consuming and storing the accumulated entropy of everything that ever existed within it. Those black holes then evaporate, erasing the gravitational entropy they stored, and leaving behind a pure radiation field with no internal scale, no internal clock, and a near-zero gravitational entropy. That radiation field, being composed entirely of massless photons, undergoes the conformal geometric transition, the mathematical equivalence between infinite scale and zero scale that emerges when no mass is present to define a reference and ignites the Big Bang of the next universe, which is born in a low entropy state, which expands and forms structure and burns its stars, which approaches thermal death. The cycle continues without beginning and without end. The Hawking points, those anomalous circular temperature patterns in our cosmic microwave background, represent the moments where the most energetic black hole evaporation events of the previous universe transfer their concentrated energy across the conformal boundary into the plasma of our own newborn cosmos. They are the fingerprints of a reality that ended before our time began, pressed permanently into the structure of our universe's earliest observable state. They are not noise. They are not artifacts. They are the most direct observational evidence available for the existence of a universe that preceded our own. Consider what this means for the concept of time itself, and specifically for the paradox of how anything can be older than the beginning of time. Our intuition treats time as a universal river flowing in a single direction, carrying everything along with it at a uniform rate. But that picture is precisely the illusion that relativity dismantles. Time is not a background against which events occur. Time is a consequence of mass and velocity, a local phenomenon produced by the physical properties of the objects experiencing it. Remove all mass from the universe, as the final evaporation of the last black hole does, and you remove the physical basis for time's passage. A universe containing nothing but massless photons is a universe in which time, in the physical sense, has ceased to function. There is no process by which duration can be measured. There is no object whose state changes in a way that could serve as a clock. Time, as a meaningful physical concept, has ended. And in a universe where time has ended, the question of how long that universe must wait before the next Big Bang occurs becomes incoherent. Waiting requires time. If time does not exist, no waiting occurs. The transition from the frozen endpoint of one universe to the explosive beginning of the next does not span a duration. From the perspective of the only things present, the massless photons that carry no experience of time, the end of one cosmic era and the beginning of the next, are not separated by any interval. They are the same geometric moment, the same mathematical boundary, crossed without any experience of crossing. This is how light becomes older than time, not through any violation of physical law, not through any mystical property of photons that places them outside the normal rules of the universe, but through the precise and rigorous consequence of what it means to have zero mass in a relativistic universe. A photon born in the final evaporation burst of a black hole from a previous cosmic era does not experience the conformal transition between that era and ours. It does not wait on one side of a boundary and then cross it. For the photon, there is no boundary to cross, because the boundary only exists as a temporal concept, and the photon has no access to temporal concept. It simply continues its path, and that path, without interruption or delay or any experienced transition, leads from the dying cosmos of a previous eon directly into the blazing plasma of our own universe's birth. The light that carries the signature of those ancient black hole evaporation events into our cosmic microwave background is, in the only sense that the physics supports, genuinely pre-universal. It originated in a reality that preceded our time. It crossed a boundary that our physics marks as the beginning of everything. And it is detectable not as a theoretical prediction awaiting future confirmation, but as an observable pattern already present in the most comprehensive maps of our sky that human technology has produced. The implications for our understanding of what we are and where we exist are significant. Our universe is not the first expression of reality. It is one cycle in a sequence, without beginning and without end, one expansion and contraction in an infinite chain of cosmic eras, each born from the death of its predecessor, each carrying forward the energy but not the disorder of what came before. The Big Bang that produced our cosmos was not the creation of something from nothing. It was the ignition of a new era from the perfectly purified remnants of a previous one, a transition so geometrically precise that it resolves the singularity problem of standard cosmology entirely. There is no mathematical breakdown at the Big Bang within the conformal framework. There is only a geometric transition between states, governed by the same equations that describe the rest of physical reality. Our bodies, the stars visible on a clear night, the planet beneath us, all of it is built from energy that traces its lineage to a cosmos that no longer exists, filtered through the purifying mechanism of a black hole evaporation cycle that reset the entropy and allowed structure to emerge again from a clean initial condition. We are not the children of nothing. We are the product of a process so vast in its timescales and so elegant in its mathematics that comprehending it requires abandoning almost every intuition that biological evolution equipped us with for navigating a world of medium-sized objects moving at medium speeds. Some find this vision deeply disorienting. The realization that our universe is not the singular, unique, and repeatable act of creation, but rather one breath in an endless cosmic respiration can feel like a diminishment. Our civilization, our history, the entire 1.4 billion year story of our universe amounts to a single cycle in a chain that has no beginning and will have no end. But there is another way to hold that realization. We are, for however brief a span our universe persists, the part of this infinite process that became aware of itself. We are matter complex enough to examine the equations that govern its own eventual dissolution. We are the mechanism by which this particular aeon looks at the light crossing from the previous one and recognizes what it is seeing. That is not a diminishment. That is the most extraordinary thing that physics has revealed, that the universe, in at least one of its cycles, produced something capable of reading the message written in the light of a dead cosmos. The light is older than our time. The evidence is written in our sky. And the cycle continues, indifferent to our presence but no less magnificent for it. If this kind of unflinching, mathematically honest exploration of reality is what you come here for, subscribe now, share this with someone whose mind is ready for it, and tell us in the comments which part of this framework changed the way you see the universe, because there is no more important conversation happening anywhere in science right now.